Okay. These are the periodic properties we are discussing. So what are the periodic properties? So now I am dividing two types. Some of the belongs to physical properties, some of the belongs to chemical properties. See here in this slide, periodic trends in the physical properties. See shielding effect and nuclear effective nuclear charge, atomic radius, ionic radius, ionization enthalpy means ionization energy, electron gaining enthalpy, electron negativity. So these are the periodic properties. So right now coming to the periodic trend in the chemical properties, periodicity of valency or auxiliary state, anomalous properties of second period elements, chemical reactivity. So these are the physical properties and chemical properties. Once again, I say look at so shielding effect and effective nuclear charge, atomic radius, ionic radius, ionization energy or ionization enthalpy, electron gaining enthalpy, electron negativity. Right? So these are the physical properties. And chemical properties, auxiliary state or valency state, and anomalous properties of second period elements. Anomalous means maybe differently showing the properties, some changes. Now chemical reactivity, either acidic nature or basic nature or metallic or non-metallic or like conductor or insulator, that what has reactivity that we will see. Sharma, are you follow me?
Yes.
So let's see one by one. What is shielding effect? Before go to the what is the okay, shielding effect and effective nuclear charge. First, shielding effect. So shielding is a protective layer. Shield. Am I right?
Yes.
So here effect. What is shielding effect? See, so nuclear charge. Say this is according to atomic theory. Bohr atomic theory. Atom consists of nucleus. Center at the center of the atom is a nucleus having a protons and neutrons having a positive charge. Now electrons are revolve. Negative charged electrons are revolved around the nucleus. Am I right? So outermost electron is revolve around the nuclear charge. So here revolving electrons having two equivalent forces, either centripetal force and centrifugal force. Both are equal forces working upon. Now, so what happened here? So here the nuclear charges, actual nuclear charges affected towards the nucleus, the electron of the nuclear charge. See, so here some of the nuclear charges repelled due to presence of inner electrons. So some of the inner electrons which are act as a shielding electron, shielding. It stop their forces of outer nuclear charge. So this here what finally nuclear charge is reduced. So here this is the inner electron where here this inner orbit here act as a shielding. Understand?
Yeah.
So let's see. Let us see. Come to the definition. The decreasing in the nuclear charge. The decreasing in the nuclear charge or outermost shell electron. This is outermost shell electron. The decreasing nuclear charge due to repulsion causing by inner shell electrons. So what repulsions are there? Electron repulsions between inner shell electron and outermost shell electron. Here both are negatively charged, where the like charges are repelled and opposite charges are attracted. That is the basic principles where it is go either magnetic chapter or either electrical chapter. Do you know that here opposite magnetic poles are attracted?
Yes.
And like poles are repelled. Here also in the electrical chapter also. So here both are negatively charged pieces, electron both are repelled to each other. So due to these repulsions, here between the inner electrons and outermost electron, due to the repulsion, finally it lose their reduce their nuclear charge, original nuclear charge. So finally something, the nuclear charge is reduced. So this phenomenon is called a shielding effect of inner shell. So once again say definition: the decreasing in nuclear charge on outermost shell electrons, means here nuclear force of attraction, the decrease in nuclear force of attraction, nuclear charge nothing but nuclear force of attraction on the outermost electrons due to repulsions caused in inner electrons. Repulsion caused in electron is known as a shielding effect of inner shell. Or understand?
Yeah.
Yeah, right. So this shielding effect, this is the one of the property happening. So just we are observing in the periods and groups what happen, increasing or decreasing. Suppose let me see in the next slide. Okay, before go to trend, just know once again one more here the term is, remember what is effective nuclear charge. So as shielding effect is completed, now effective nuclear charge. So due to the shielding effect, the nuclear charge is lowered on outermost shell electrons. The net nuclear charge acting on the outermost shell electron is known as effective nuclear charge. So due to shielding effect, the final nuclear charge is decreases on the outermost shell. So that what happened? The remaining, the net nuclear charges acting on the outermost shell is known as effective nuclear charge. Here, effective means how much net nuclear overall nuclear charge. Initially, net nuclear charge. See from this diagram. So observed nuclear charge maybe here's something, but the nuclear charge is reduced to the inner electrons. So finally net nuclear charge is acting on outermost shell electrons. So that is called effective nuclear charge, means something nuclear charge is reduced. So that here effective nuclear charge is denoted with Z star or ZF. Here the formula is Z minus sigma. Here Z is atomic number, here sigma is a screening constant. Say here atomic number should be equal to nuclear charge. So understand, Verma?
Yes.
Sharma, sorry. So here Z is the nuclear charge or atomic number, both are same here. Here you have to apply one electron. See, look at the applying. So there is a formula, little bit systematic procedure for calculating the effective nuclear charge of the electron in an atom. Let me see one by one. If the electron resides on S and P orbitals, then the electron in the principal shell, principal cell mean n is equal to 1. Then the sigma value is just you have to this is this slide totally belongs to for screening constant, where here sigma is the screening constant, that value. So sigma that value 0 to sigma the contribution. Next, each electron in the same principal shell contributed to 0.35 to sigma. Sigma means the screening constant. So electrons in the n-1 shell means inner shell each contributes 0.85 to sigma. And electrons in the deeper shell each contributes 1.0 to sigma. See, that means here it tells about sigma values of the particular electrons, remaining electrons. So that okay, right, this slide only belongs to S and P orbitals. If in case of D and F orbitals, for sigma values, this is the if the electron is resides in the d or f orbitals. Say if the all electrons in a higher principal shell contributes 0, means 0 to sigma means the each electrons in the same shell contribute 0.35. Means here the first point indicate all electrons in the higher principal shell contribute 0. 0 means here those electrons you have to find. We need to find the effective nuclear charge for that electron on that value is 0. Means the themselves that that electron outermost shell what electrons you want to find the effective nuclear charge. Themselves not a shielding. The remaining electrons are contributing shielding. So that's why that 0 is put. So each electron in the same shell contribute 0.35. Same shell means outermost shell, where your principal shell, outermost shell, that value is 0.35 to sigma. And all inner shell, that means inner n-1 penetrating shell, that value lower contribution. See that value is 1.0. So finally, I'm here. This is the tabular form. It gives the clear information that values. So electrons in the orbital as either maybe s or p orbitals, either or d or f orbitals. For s or p orbitals, same values. So the per electron, each per electron in the orbital. See, suppose the electron present in the outermost shell, that value is 0.35. These all values are sigma values, means constant values. And similar d and f orbitals also same value for nth orbit, means outermost shell. Now coming to the inner orbitals, inner orbital electrons, if in case the orbital belongs to s and p orbital, that value is 0.85. If in case electron is belongs to d and f orbital, that value is 1. Remaining near to the nucleus, that all are 1. Either s or p orbital, sp, d or f orbital, 1. So by calculating or by applying these values and calculating for effective nuclear charge, then we can easily understand. So now we want to calculate do the one problem. So calculate the effective nuclear charge Z star for the 2p electron of fluorine. Understand?
Yes.
See here, what we will do here, we have to need to calculate effective nuclear charge for particular electron in the atomic structure in the electronic configuration, not for all electrons at a time. So have to need calculate the one electron that we selected firstly outermost shell electron. See here 2p electron. So here for fluorine atom example 1s, the atomic number is 9. The electronic configuration 1s2, 2s2, 2p5. Here 2 is not mentioned. 2s2, 2p5.
Yeah.
Okay, all right.
Yeah.
See, the electronic configuration 1s2, 2s2, 2p5. In this 2s2, 2p5, but in the problem, given problem to only calculate 2p electrons, means outermost shell electron, that should be p electrons. So that only one electron have to calculate the effective nuclear charge for that particular electron. Means the particular electron is outermost shell. Just you have to calculate the effective nuclear charge. Sure, what is the effective nuclear charge? Means decreasing the original nuclear charge. Why? Means due to screening effect, due to inner electron repulsions, the final nuclear charge is reduced something. So what I'm saying, understand?
Yes.
So by using formulas, you can easily calculate. What is the formula? Main formula is effective nuclear charge is so this first you first need to calculate screening constant. So for one electron, outermost shell electron, see the outermost shell electron. I want to draw the diagram. This is the nucleus. Okay, all right.
Yes.
This is what is it? First orbit. This is say second orbit.
So it's S.
Am I right?
No. Yeah.
How many electrons in the first orbit?
2.
Good. One electron. Here another electron. How many electrons in the second orbit?
8.
For fluorine.
No, for fluorine would be 7.
7. So here 1, 2, 3, 4, 5, 6, here 7. 7. So look at, suppose I want to calculate the effective nuclear charge for this electron, red color symbol. Understand? So
Yes.
right, suppose you have to need to calculate effective nuclear charge for 2p electron for this electrons. So first how many electrons are shielding? In even this orbital, main orbitals, remaining 6 electrons also shielding. They 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 are they are act as a screening. They are repulsions in between the electron repulsions in the same shell. Am I right?
Yeah.
Due to these repulsions in the same shell electrons, that then effective the nuclear charge is reduced. That's why you have to calculate for apply these electron how much is repulsion by using this formula, by using sigma star screening constant. Understand? So screening
Yes.
constant. So here this formula it tells about S and P orbitals, the outermost shell n electrons. That value sigma value is 0.35 for each electron. Understand? So here remaining electrons, this is the 6 electrons. Few are belongs to 4 are belongs to p electron, p orbital. 2 are belongs to, understand, 2
Yeah.
electrons. So here this is the suppose 2s1. This is 2s1. Sorry, and right. This is the 2s1 electron. This is 2p1, 2px1, 2py1. Suppose this is the 2s1, 2s22, 2px1, 2px1, 2px1 having 2 electrons, 2px, 2py, 2py, and these are the 5 electrons. So totally, just apply how many electrons in the repulsions. This electron, how many electrons repel with the repulsion with another electrons? See, 1, 2, 3, 4, 5, 6. Am I right? 6 electrons.
Yeah.
So now multiply with 6 for each electron 0.35, and how many electrons in the outermost shell? Left electrons, 6 electrons. So just multiply with 6 electrons, remaining 6 electrons. So 6 into for 2s and 2p, both s and p orbitals same value 0.35, 6 into 0.35, 2.10. This is for outermost shell electron screening constant, screening effect. Now apply the inner electrons. Inner electron, how many electrons are there? 2 electrons. Am I right?
Yes.
So now
Wait, why is
calculate,
it 6? Wait, why is it 6 for the last one?
because you have to need calculate for 1 electron. That's why I'm here red mark. I'm putting red mark. So for calculating, selecting 1 electron, so in the question, calculate the Z star for the 2p electron. 2p electron means this one, selected
Oh,
electron. This is the
yes.
selected electron. So for this electron, have to calculate effective nuclear charge. Don't count this electron, because our target is effective nuclear charge for this electron.
Got it.
Understand? This is the repulsion with other electrons. So
Yeah.
that's why I selected remaining 6 electrons and multiply with 6 into 0.35. Got it?
Yes.
So now and calculate for inner electrons, penetrating shell, inner electron. Okay, understand? How many electrons are the inner shell? 2 electrons. The 2 electrons are belongs to s orbital. Clear?
Yes.
So that value is inner electron for s and p orbital 0.85. See, look at this table. Hello, Sharma?
Yeah. 0.85.
2 into 0.85, total 1.70. This is values for only sigma. You have to calculate for it. So finally, see, for inner electron 1.70, for outermost electrons 2.10. Now add these two electrons, these two values, sorry, these two values. Finally, we get sigma is 1.70 plus 2.10 is equal 3.80. This is the screening constant only, not calculating sigma star. Sigma star formula is there. Sigma star is equal to sigma minus sigma star, sorry, Z star. Z star is effective nuclear charge. That formula is Z minus sigma. Previously I told. Understand?
Yeah.
Or may once again I repeat. See, look at that formula is. See this formula. What is the Z star is equal? Z minus sigma.
Yes.
Hello?
Yeah.
So Z is the nuclear charge or atomic number. Sigma is the screening constant. Till now, what you have calculated, only screening constant. So that formula I have to substitute here. So here say Z star is Z minus sigma. Z values may be atomic number or nuclear charge 9. For fluorine atomic number is 9 here, right? And sigma is 3.80. Now substitution from 9, what do we get? 5.20. Sigma star is effective nuclear charge value of fluorine, particular for particular electron 2p, that value is 5.20. Actually, original nuclear charge is 9, but due to repulsions, that value is reduced to 3.80, reduced. The finally effective nuclear charge is 5.0. Understand?
Yes.
For particular this electron. So once again I'm saying, for this particular this electron, the nuclear charge is originally 9, but it reduced by due to repulsions of the inner electrons and the same with the other electrons due to electron repulsion, that reduced values 3.80, the screening constant values. So finally effective nuclear charge is 5.20. Understand?
Yes.
So similarly, you have to observe now coming to the trend for effective nuclear charge. What happened in the, let us first initially taking the periods in the period from left to right. First I am taking the left to right second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Observe. So what happened here? Effective nuclear charge for outermost electrons only I selected, not for all electrons. Outermost electron, the effective nuclear charge is lithium is 1.3, beryllium is 1.95, boron is 2.6, carbon is 3.3, nitrogen 3.9, oxygen 4.6, fluorine 5.2, neon 5.9. Am I right? See, look at.
Yes.
So what happened? Just now we calculated fluorine value. How much is?
5.2.
4.2. Just now, previous slide, 4.2.
Yeah, 5. Oh, 5. Oh, yeah.
Tell me, any doubt?
No.
So similarly, we have to calculate for each atom for outermost electrons. Then we get these values. So just now write each value like just are observed in the periods from left to right. So what happens? See that values increases. Understand?
Yes.
So how to increase? Just here like a 0.6 per next group by adding. So 1.3 plus 0.65, next value is 1.95. For 1.9 value is added to 0.65, 2.6. So finally effective nuclear charge rapidly increases along the period in the left, from the left to right, from lithium to neon. Effective nuclear charge increases. How they increases? Rapidly increases. Rapidly, regularly, constantly increases. Just the differentiation value in between two elements, the effective nuclear charge differentiation value is 0.65. Finally, what observed here? Effective nuclear charge in the period, the trend is the periodic property of that is the periodic property that is called effective nuclear charge that observed in the period from left to right increases. How to increases? Rapidly increases. How much increases? 0.65 times. Understand?
Yes.
So now observe groups. From top to bottom, I'm taking first group, hydrogen, lithium, sodium, potassium, rubidium, cesium. And now effective nuclear charge is just here 1 for hydrogen 1. Why only one hydrogen? Why not decreases? Can you guess it?
Because there's only one electron.
One electron. Very good. Very good. Because there is no inertial electrons. So that is only one electron. Z value is 0. Sorry, Z sigma value is 0. So now similar coming to the 1.3, that value is increases here. Now coming to the sodium, 2.2 here increase, again increases. But in the coming to the after sodium, potassium, rubidium, cesium, francium, that effective nuclear charge is constant. Means here the groups from top to bottom, the effective nuclear charge is initially slowly increases, later constant. Slowly, the effective nuclear charge of the sigma star, Z star, that way, in the groups from top to bottom increases slowly along the group. Example, see, this is the example. Understand?
Yes.
Right. So this is the effective nuclear charge trend or a periodicity. What happened? Next properties, I think you have to clear about effective nuclear charge and shielding effect. Are you clear? Any doubts?
No doubt.
If you have, just you have to calculate yourself, check it whether the sodium or take a one atom either lithium or sodium 2.2, whether it is right or wrong. Take a white news or rough paper and apply these formulas. Previously, what I said, these formulas, this method, this tabular form, have to check it. Sodium value is 2.2 or not. After completion of the class, just take a white paper or check it whether the sodium values sodium 2.2, either check it any carbon 3.3. Is it answer right answer or wrong answer? Understand?
Okay, yes.
Have you take any screenshot? Or note?
No, not yet. You want me to take screenshots?
You for
I
yourself. Or
yes,
writing.
I thought you were gonna send the slide deck afterwards. That's why I haven't been taking it.
Okay. Okay, then I will share to you. No problem.
Okay.
So I think understand what happened in the periods from left to right, effective nuclear charge. Tell me, either increase or decrease.
Left to right
Mm.
would be increase.
Rapidly increase. Good. Now groups from top to bottom.
Would it
Effective
increase
nuclear
as
charge.
well?
Yes, how to increases? Either rapidly or slowly.
Um,
See, look at this table. So initially, what
so gradually,
gradually or slowly? Slowly increases.
slowly.
Good. That's remember. So now coming to the second property, that's very well known, atomic radius. So in the mathematics, circle radius is there. Circle. So the distance between, what is the circle radius?
Oh, circular radius is half
Definition.
like the length from one side to the middle.
One side means the distance between center to and circumcircle that
Yeah.
curve. Here, similar here also, what is the atomic radius means